Hello everybody. Today we're going to cover 3.3, which is product and quotient rules. So up to this point we've learned how to take the derivative using definition of the limit as well as power rule. Okay. So currently I would choose power rule for a problem like this, but in order to use power rule as this warm-up, I would have to distribute the x squared. Okay, so now I'm working with a function that says 9x cubed plus 2x squared. And power rule would give me 27x squared plus 4x. Okay. However, not every problem can we simplify in such an easy way, so we're going to want to use the product rule when necessary. Product rule, f of f times g prime of x is f of x times g prime plus g of x times f prime. Now, this is how the textbook defines it, but you're going to find me referring to it as this instead. F prime g plus f g prime. That's just the way that I tend to write it out. It's consistent with our quotient rule, and it just, for me, works a little bit better. Obviously, it doesn't make a difference. It's equivalent, so you can use it as the book wrote it or my way. I just don't want you to get confused. Okay, so essentially here we're taking the derivative of the first term, leaving the original second, plus derivative, keeping the original first, and then derivative of the second. So we could walk through the first example that we just did using product rule instead. So f prime g plus f g prime, which would mean I would have 2x times 9x plus 2 plus x squared times 9. And in order to compare my answers, at this point then I could distribute and combine like terms. So I have 18x squared plus 4x plus 9x squared, which would give me 27x squared plus 4x. Okay, so we already did this. Now we look at something that's a little bit more complicated. In this example, I probably would not want to FOIL before I began, so I probably would choose to use the product rule. But there will be times when you can avoid the product rule, and distributing just makes more sense in the beginning. So the first set of parentheses is the f, the second set of parentheses is the g. So y prime equals f prime g plus f g prime. So f prime, the 2 goes to 0. X to the negative 1 would become negative x to the negative 2. G stays, plus f stays, and g derives to 3 halves x to the 1 half. Okay, there's going to be times when you have to clean your answer up, and there's going to be times when you can leave it. Later on in this chapter, we'll be taking higher derivatives, so my rule of thumb is just derive it to the point where you would be comfortable deriving it again. So if I left it here, that means that I have to use 2 product rules, and if I can avoid that, I'd rather do so. So in this case, I will distribute. So I have negative x to the negative 1 half minus x to the negative second plus 3x to the 1 half plus 3 halves x to the negative 1 half. So I have 2 like terms here that I can combine. So I have y prime equaling 3x to the positive 1 half plus 1 half x to the negative 1 half minus x to the negative second. So here's an example. Our notation is a little bit different. We also don't have parentheses separating f and g. So d over dt is the notation telling us to take the derivative of this expression with respect to the variable t. Okay. So this this is kind of like the instruction. Then we can separate t squared from et with a multiplication symbol. So t squared is our f, e to the t is our g. So f prime g plus f g prime. Okay, so f prime is 2t, g stays, plus f stays, and g prime, remember the rule for e to the x remains e to the x, so we have e to the t here. Okay. This answer is totally acceptable, but some people might choose to factor e to the t out and leave an answer like this. When deriving with e, especially with product rule, you are going to see some patterns and you are going to be able to factor e's out. Sometimes that's helpful, sometimes it's unnecessary. So either way is fine. Okay. I'm going to leave this one for you to try, so pause the video, work through it, use the product rule to find the derivative here. Okay, when you finish, unpause and check your work. So in this case, it starts out pretty long and complicated, but when you do FOIL and distribute and combine like terms, you reduce this to just a binomial at the end. Okay. One pointer in the beginning, that 1 over x term, it's important to rewrite that as x to the negative first and then apply the power rule to it. Okay, the second rule in this section is the quotient rule. Okay. So product rule, again, you can avoid it, you can FOIL most of the time, it just doesn't always make sense to. Quotient rule is a little bit harder to avoid, so it is something that you definitely have to follow. Again, here's how the book defines it. I'm going to write it a little bit differently so that it is consistent with our product rule. Notice that with a quotient rule, the numerator has subtraction. Therefore, the order that we derive does matter. Right? So f prime g minus f g prime. There is almost the product rule in the numerator. Okay, so in the product rule, it doesn't matter which one you derive first, as long as you're deriving one and keeping one in both of the terms, because it's separated with addition. In the quotient rule, you have to derive the numerator first, subtracted by, then you're deriving the denominator. The denominator is g squared, so the original bottom squared. Okay, so here's our first example. The numerator is our f, the denominator is our g. Okay. So write down the rule. I highly recommend every time you do these problems in the beginning, just write that rule down. It'll help you memorize. So f prime g minus f g prime over g squared. And the more complicated we get with these rules, sometimes I also write it out using this notation. So I'm going to fill in for f, the numerator, x, and keep that little tick mark, implying that I still need to derive it. Because as we move through this chapter, there's going to be multiple rules, and they will be embedded in one log problem. So right now, I'm just kind of filling in and indicating that I still need to derive these terms. So I've got my quotient rule ready to go. Now I just have to derive those two pieces, and I'll be done. So x derives to 1. 1 plus x squared stays. X stays. 1 plus x squared derives to 2x. So as a rule of thumb here, simplify your numerator, keep your denominator. So we have 1 plus x squared minus 2x squared in the numerator. So 1 plus x squared minus 2x squared goes to 1 minus x squared over denominator squared. Okay, let's do an example with e's. Similar notation as the last time we saw the e's. Take the derivative of the expression with respect to t of e to the t divided by e to the t plus t. So we're doing quotient rule, which is f prime g minus f g prime over g squared. Fill in your rule. E to the t prime times e to the t plus t minus e to the t times e to the t plus t prime. E to the t plus t squared. So I have indicated that I still have two terms that I need to derive, so I'll do that in my next line of work. Remember, e to the t, that's going to stay. So e to the t plus t would go to e to the t plus 1. Okay. So I am going to distribute, and I have e to the 2t plus e to the t times t minus e to the 2t minus e to the t over e to the t plus t squared. E to the 2t's cancel up top. You can choose to factor the e to the t out of what's left or not. E to the t times t minus e to the t over e to the t plus t squared. Okay. We have two more examples in this lesson. This one I'd like you to try on your own. So again, pause the video, work through it, and then compare your work. Okay, so final answer, 3x to the 4th plus 4x cubed plus x e to the x divided by quantity x plus 1 squared. Okay, so the extension of this is, of course, back to this tangent line. So if we want to find the tangent line to the graph of this rational, 3x squared plus x minus 2 over 4x cubed plus 1 at x equals 1. Remember, we're always structuring this type of a question as point, slope, and then we can do our line. So the point is coming from our original function, a comma f of a. The slope is coming from the derivative, and the line is putting that together. So y minus f of a equals f prime of a times x minus a. So the a value is 1 in this case, so I need to know what f of 1 is. So 3 plus 1 is 4, minus 2 is 2 up top, over 4 plus 1 is 5. So 1 comma 2 fifths is our ordered pair, is our point. Our slope, first I'm going to find f prime of x using quotient rule. And once I have it, then I plug 1 in. So when you're doing it at a point, we don't have to simplify like we've been doing previously. I'm just going to derive it and then input 1 right away. So 6x plus 1, that's f prime, times g, minus f times g prime, divided by g squared. Okay. Now f prime at 1. So 6 times 1 plus 1 is going to be 7. 4 plus 1 will be 5. 3 x squared plus x minus 2. We've already done that before, if you remember, in the original, because that's just f original. That gives us a 2. G prime will give us a 12 over g squared. That's the denominator from the original, so 5 squared, or 25. So 35 minus 24 gives us 11/25. That is the slope of the tangent line. So final answer, pulling this together, y minus 2/5 equals 11/25 times x minus 1. And leave it in that format. All done. Okay, so that was 3.3 product and quotient rules.